We all know how water moves, or at least we think we do. We see its drip, flow, and splash. But in fact, we're missing the breathtaking show that water puts on all around us every day. The spectacle that unfolds right in front of our eyes is beyond our capacity to see. But if you know how to look, it's possible to enter this invisible world. John Bush is a professor of applied mathematics at MIT.
My field of study is fluid mechanics, so basically the dynamics of fluids, liquids, and gases. I've always been excited about the aesthetic aspects of fluid mechanics. There's a beautiful visual aspect which gets me out of bed in the morning.
Bush and his team at MIT spend their days trying to learn about water and other fluids, from the way they flow through a space to their complex geometric patterns. And every day, Bush confronts the same challenge.
The problem is not that things are very small, it's that they're very fast. Whenever raindrops hit a puddle, for example, they're very fast flows, which we can't see with the naked eye. When you put milk in your coffee, when the last drop of cream goes in, it's gone in a flash of an eye.
But in his lab, Bush and his team have devices to slow down time and get an unprecedented look at what's normally hidden. These specialized high-speed cameras shoot 10,000 frames a second. They can capture images 400 times faster than the human eye.
And just an object hitting a water surface is very complex, and one sees higher and higher levels of complexity with faster and faster cameras. The goal here is to see something that no one has ever seen before.
And what Bush sees is astonishing. Water doesn't do what we think it does. When you pour water into water, the last droplets do a very quick but amazing dance. It's invisible in human time, but we can see it here. Scientists call this phenomenon the coalescence cascade.
You take a drop of water and you place it on a water bath. You ask 1,000 people and 999 will say it simply goes like this. It basically merges with the underlying bath.
Exactly half of the droplet disappears into the water underneath. The other half becomes a smaller droplet that shoots back into the air.
And then it dumps its contents again, and now a drop of a quarter the size jumps up, and it keeps going. We've seen as many as 7 such events in a coalescence cascade.